Hello everyone, my name is Vasso Gkatsi and I'm a PhD researcher at the Power Electronics and EMC group at the University of Twente. I'm also ESR 13 of the Peter project. Today I'm going to present a common electromagnetic phenomenon demonstrated on a printed circuit board, the phenomenon of crosstalk. Crosstalk is referring to the unintended electromagnetic coupling between wires or PCB traces that are in very close proximity. It is a near-field coupling problem, which means that the electric and magnetic fields can act independently and the one can influence the other. The crosstalk can influence the radiated and conducted emissions of a product as well as its susceptibility. But let's go on to the board. So this is the crosstalk board. As you can see, it consists of 3 SMB connectors here and 3 SMB connectors here. It also consists of 3 traces. The middle trace is the active trace, and that means that the transmitting signal will be through it. The other 2 traces are acting as the passive traces, and that means that we can observe the crosstalk phenomenon on these 2. As you can see, one is further than the other, and we will see how this affects our results later. Also, here you can see a switch that is terminating the active trace, and it can be set in 3 different positions, which correspond to the characteristic termination, open termination, and short. So today we're going to do 2 experiments in order to observe the crosstalk phenomenon. We will first compare the 2 traces that I showed before, and as you can see, one was closer to the active trace and one was further away, so we will see this difference. And later we will compare actually the different active trace termination loads. So we will see what happens when the active trace is terminated in the characteristic load, open and short terminations. Now we're going to measure the near-end crosstalk of the trace that is closer to the active trace, so this one right here. For this measurement we will use a VNA and 2 cables, which you can see here, and we will see the results through the laptop. We will measure the S21 parameters, so we will connect the port 1 to the active trace. And then the active trace is terminated in a characteristic termination, which is set by the switch. And port 2 we will place on the passive trace, which we will measure now. And then we will terminate all the other traces. Now we are ready to sweep through frequency. We will sweep through the frequency range of 1 MHz to 400 MHz. Now we will repeat the same measurement that we did before, but in the trace that is a little bit further from the active trace. Therefore, we will change the connections. We will remove the load from this trace and connect port 2 and connect the load to the previous trace. Now we will sweep again. As you can see, the graph of the new measurement is similar to the graph that we measured before, but it tends to be lower. This is due to the distance between the traces, which is in our new measurement a little bit bigger than before. Therefore, we can say that the distance is an important parameter that actually can minimize the crosstalk effect. So the crosstalk can also be affected by the loads that can be in one or the other end of the traces. Now we will change the switch to the position of the short termination, and we will sweep through frequency. The short termination you can see on the screen as the blue curve. Now we're going to change the switch to the last position, which is the open termination, and we will sweep again. So as we can see from the screen, the lowest crosstalk presents the pink line, which corresponds to an open-ended termination, and the highest crosstalk presents the blue line, which corresponds to a short-ended termination and means that the inductive crosstalk is dominant. In the higher frequencies, the trace acts as electrically long. Therefore, the wave propagates down the line, and when the line is ended on an open or a short termination, then we have the reflections which amplify the crosstalk. The case of the This case doesn't happen in the characteristic impedance when the line is loaded to the characteristic impedance, and that's why we have the lowest crosstalk. The crosstalk of the characteristic impedance is the green line.